Imagine looking up at the night sky, believing every object moving through our solar system belongs here. For centuries, that's exactly what humanity assumed. Then, in October 2017, everything changed. Astronomers detected what first appeared to be an ordinary point of light. But as telescopes tracked its path, something astonishing emerged. It wasn't orbiting the sun. It wasn't trapped by our solar system's gravity. Instead, it was racing through space on a trajectory that could only mean one thing: it had come from another star. For the first time in recorded history, scientists were observing a confirmed interstellar visitor passing through our cosmic neighborhood. They named it ʻOumuamua, a Hawaiian word meaning a messenger from afar arriving first. At first, the discovery was exciting. But excitement quickly turned into confusion. The more astronomers studied this silent traveler, the less it resembled anything they had ever seen before. Its shape was bizarre. Its motion was even stranger. And what scientists discovered next would transform a remarkable discovery into one of astronomy's greatest modern mysteries. On the night of October 19, 2017, high above the Hawaiian Islands, the Pan-STARRS 1 telescope scanned the sky like it had countless nights before. Then, it detected a faint object unlike any previously recorded. At first, astronomers assumed it was just another asteroid. But as more observations came in, the calculations became impossible to ignore. Its trajectory wasn't elliptical like ordinary solar system objects. It wasn't gravitationally bound to the sun at all. Instead, it was following a steep hyperbolic path, moving so fast that it could only have originated beyond our solar system. The realization sent shockwaves through the astronomical community. Humanity had just discovered its first confirmed interstellar visitor. Scientists around the world immediately pointed their telescopes toward it, racing against time. The object was already leaving, disappearing back into the darkness at nearly 95,000 kilometers per hour. Every hour mattered, because once it was gone, it would never return. As observatories gathered more data, the excitement of discovery quickly turned into confusion. Oumuamua wasn't behaving like an ordinary asteroid or even a typical comet. Every new observation seemed to raise another question. As it tumbled through space, its brightness changed dramatically, becoming up to 10 times brighter and dimmer over just a few hours. To astronomers, that suggested something extraordinary. The object was either extremely elongated or remarkably flat, far more unusual than most known objects in our solar system. Then came another surprise. Despite passing relatively close to the sun, Oumuamua showed no visible coma, the glowing cloud of gas and dust that normally surrounds an icy comet as it warms. Telescopes searched carefully, but the familiar signature simply wasn't there. An object from another star, with the shape of almost nothing scientists had seen before, and none of the expected behavior of a comet. Just when researchers thought the mystery couldn't deepen any further, precise measurements revealed something even stranger. It wasn't moving exactly as gravity predicted. Just when astronomers believed they had identified every unusual feature of Oumuamua, the data revealed something even harder to explain. It wasn't simply traveling through the solar system, it was gradually accelerating. Not by much, but enough to catch the attention of scientists around the world. Normally, an object in space follows a path almost entirely determined by gravity. If an icy comet passes close to the sun, heat causes frozen gases to erupt from its surface, creating tiny jets that act like natural thrusters. This process can slightly change its speed and direction. But Oumuamua presented a contradiction. Careful measurements showed a small but measurable non-gravitational acceleration. Yet despite intense observations from some of the world's most powerful telescopes, there was no visible cloud of gas, no bright comet tail, and no clear evidence of the outgassing normally responsible for such motion. Astronomers began proposing explanations. Perhaps the escaping gas was too faint to detect. Perhaps the object contained unfamiliar materials that behave differently when heated by the sun. Or perhaps humanity was witnessing a type of interstellar object never seen before. Every new hypothesis answered one question and created two more. Because if gravity wasn't telling the whole story, then what invisible force had quietly nudged this silent visitor as it crossed our solar system? The search for that answer would soon ignite one of the most controversial scientific debates in modern astronomy. Then came the idea that turned a scientific mystery into a global controversy. In 2018, Harvard astrophysicist Avi Loeb suggested that before dismissing every possibility, scientists should also consider an extraordinary one. What if Oumuamua wasn't entirely natural? His argument wasn't that it was alien technology, but that its unusual acceleration, strange shape, and lack of a visible comet tail deserved a broader discussion. One proposed possibility was that the object could behave like a thin light sail, pushed ever so slightly by sunlight itself. The reaction was immediate. Some researchers welcomed the debate, arguing that every hypothesis should be tested against the evidence. Others strongly disagreed, pointing out that extraordinary claims require extraordinary evidence and that no direct observation supported an artificial origin. Soon, the discussion spread far beyond scientific journals. Headlines around the world transformed a careful scientific hypothesis into sensational claims of alien spacecraft. But beneath the media frenzy, one fact remained unchanged. No telescope had captured enough evidence to prove what Oumuamua truly was. And without that missing evidence, the mystery only grew deeper. While the alien hypothesis captured headlines, most astronomers focused on a different challenge, finding a natural explanation that matched every observation. Over the following years, researchers proposed one idea after another, each attempting to solve the puzzle without invoking extraordinary conclusions. Some suggested Oumuamua might have been an unusual comet releasing gases that current telescopes simply couldn't detect. Others proposed it was a fragment of nitrogen ice chipped from the surface of a distant Pluto-like world. Another study imagined an incredibly porous cloud of cosmic dust compressed into a fragile, lightweight body. Each hypothesis explained part of the mystery, but none explained everything. Some matched its strange acceleration but struggled with its brightness. Others fit its unusual shape but failed to account for its missing comet tail. Every proposed solution seemed to leave at least one critical question unanswered. In science, mysteries aren't solved by choosing the most exciting explanation, they're solved by finding the explanation that fits all the evidence. And for Oumuamua, that explanation still hadn't been found. The deeper scientists investigated, the more they realized the greatest mystery wasn't what they had discovered, it was how little they actually knew. Perhaps the most frustrating part of the Oumuamua mystery wasn't what scientists found, it was what they couldn't. By the time astronomers realized how extraordinary the object truly was, it was already racing away from the sun, growing fainter with every passing day. There was no spacecraft ready to intercept it, no mission capable of catching it in time. Within weeks, even the world's most powerful telescopes could no longer collect enough detailed data. The visitor that had sparked worldwide debate simply faded into the darkness between the stars. That left scientists with only a brief collection of observations, just enough to reveal something unusual, but not enough to explain it with certainty. Unlike a rock recovered on Earth, ʻOumuamua could never be examined in a laboratory. Every unanswered question had to be explored using distant measurements and computer models alone. It was as if the universe had offered humanity a single, fleeting glimpse of something entirely new, and then quietly taken it back. But astronomers knew one thing for certain. If one interstellar visitor reached our solar system, another one eventually would. Although ʻOumuamua is gone forever, its story didn't end when it disappeared into interstellar space. Instead, it transformed the way astronomers prepare for the future. Scientists now know that objects from other star systems can enter our solar system, and they may be far more common than anyone once believed. The challenge is finding them early enough. New observatories, including the Vera C. Rubin Observatory, are designed to scan the night sky with unprecedented speed and sensitivity. Instead of discovering the next interstellar visitor as it leaves, astronomers hope to detect it while it's still approaching, giving months or even years to study it in detail. Some researchers have even proposed missions capable of intercepting a future visitor before it escapes forever. Imagine a spacecraft racing through space, capturing close-up images and measurements of an object that formed around another star billions of years ago. For the first time, humanity isn't just waiting for the next cosmic messenger. We're preparing to meet it. And when that moment finally comes, it may answer the questions ʻOumuamua left behind, or reveal mysteries even stranger than the first. In the end, the most remarkable thing about ʻOumuamua wasn't that it solved a mystery, it created one. For a few brief weeks, humanity watched a traveler that had spent millions, perhaps even billions, of years crossing the vast emptiness between stars before passing silently through our solar system. Then, just as quickly as it arrived, it vanished forever. Science thrives on evidence, not certainty. And sometimes, the most honest answer is also the hardest to accept. We simply don't know. Was ʻOumuamua an unusually shaped fragment of a distant world? An exotic type of comet unlike any we've observed? Or something no existing model has yet explained? Today, none of those possibilities can be confirmed with confidence. Yet perhaps that's what makes this story so extraordinary. One small object reminded us that our cosmic neighborhood is not isolated. The galaxy is constantly moving, exchanging material between distant star systems, carrying silent messengers across unimaginable distances. Somewhere, at this very moment, another interstellar visitor is almost certainly drifting toward the solar system. The only question is, will we be ready when it arrives?